Welcome everyone to our 10th Scalable Pandas Meetup. I am really excited to be here with all of you. This is so fun, and we're really excited that we have Zui Yi here with us today. And yeah, we'll dive in our agenda. So we'll do a brief recap of Meetup goals, then we'll have introductions, and then the main event will be Zui talking about Spotify with Modin and Ray. And then throughout, we'll have people can ask questions. Alejandro Herrera, who's here, Ponder Solution Architect, will also ask questions, and then we'll have some moderated Q&A at the end and audience Q&A. I also want to give a shout out to Ali is here as well. She's on a team with Zui, and then this is so funny, and it totally wasn't planned. Ali was my coworker when I was a data scientist at Coursera, and she works like on the same project with Zui. So this is so fun. So Ali can chime in with like other thoughts as we go through. Okay, so the Scale Pandas meetup. What are these meetups about? These meetups are about talking through working with pandas with really large data frames or in situations through very complex workflows, and then talking about solutions to those challenges. I sometimes think of it as like group therapy for pandas in production, people. And we're interested in producing content and material around supporting working with pandas at scale. Who is Ponder? Ponder is the enterprise-ready pandas company. We're a core maintainer of the open source library Modin, which has more than 6 million downloads now as of this week. So that's exciting. And we recently launched our first product, which is Pandas, which sits directly on a data warehouse. So you can use the Pandas API and then run everything in Snowflake or run everything in BigQuery, which is fun. Why did Ponder start these meetups? Our goal was to create a community around working with pandas at scale, and especially like getting the Pandas API, helping it become part of more production use cases. So building this community. How often are these held? These are held every month. This is our 10th one. It's very exciting. 10's a great number. And our next one will be, typically it's the fourth Thursday of every month. Our next one will happen on the third Thursday, which I believe is April 20th. And we haven't publicly announced the topic yet, but it's going to be really exciting. So definitely make sure to come to that one as well. And then lastly, how can I get involved? If you want to present, if you have suggestions for topics, you can email me at peter@ponder.io. I get to introduce Zui Yi. So Zui is a machine learning engineer at Spotify, working on algorithmic playlist generation, multi-stakeholder systems. They will explain in going forward this multi-stakeholder system idea and how what that means, like in this context of Spotify. Who are the stakeholders? Zui has a master's in computational applied mathematics at the Rochester Institute of Technology, and they and I were talking before about how Zui has so much experience in various internships that were 6 months long, so came into Spotify full time with like tons and tons and tons of real life experience, which I think is great. So we're so excited to hear from Zui about Modin and Ray use case at Spotify, and I'll turn it over to Zui to present.
And these, if I can just say, I think I'm a longtime Spotify user, and I almost exclusively use the personalized playlist features that Zui and the team have developed. So I am really excited to hear this.
Right. Yeah. Thank you. So I'm Zui. I work at Spotify. It's been 1 year since I started, almost exact to the dot, but I've interned twice before. I work in a part of a company called Personalization, and our team of 8, including Ali, in the audience here, are part of a team that basically works on ML models, the whole sequencing algorithm for the generative playlist, basically, right? So I'm here to actually talk about my experience adapting Modin for our evaluation system, right? So this evaluation system evaluates algorithms, and I'll get into that later. But we're in fact the first team in Spotify to adapt Modin, and really I expect many more to come because it's really convenient, and we actually surprisingly have the backend for the full support of the platform team, right? So The outline of this talk, right? So first, I will introduce the system. And secondly, I will explain why we're doing this migration from native Pandas to Modin, and how are we actually how we're actually implementing this speed up, and how fast with this speed up. Right. So first, an introduction to our product. So Spotify have a lot of these so-called made for you playlists, right? So we have the whole radio system, which was a different system before, but now you have a playlist. And if you right click on any track, you can go to the tracks radio, and it basically shows very similar tracks and sequenced in a way that we think you'll enjoy. We also have mixes like daily mix, artist mix that are quite different, but they're essentially mixes that generates, I believe, daily. That's literally on the homepage, so you don't have to click on anything else. You can just click on these mixes, and it will show your favorite tracks and some new tracks we think you will enjoy. And also we have this autoplay. We also own these autoplay systems, right? So every time you finish a playlist and and if no track or other playlist or other album queued, we actually autoplay tracks for you, basically similar tracks again, and things that we think that you want to listen to. And really, these products drive a large proportion of active listening. So some people just like click on these mixes and click on some random track they think they will enjoy, right? Or in active listening, meaning that they literally just autoplay the entire playlist. And yeah, this drives a huge amount of listening proportion or on Spotify, basically.
Wait, Zoe, can I ask? So you're saying that if you click on an artist and then say play that radio, is that personalized like for an individual specific?
Yes.
So it's not. Oh, I had always thought it was. Wow, that's super cool. I had always thought it was customized, of course, to that seed, but I didn't realize that it would be.
Yeah.
Oh wow.
If basically a lot of your similar artists and familiar artists that you listen to, right? Okay. So again, this is a huge proportion of the listening on Spotify. So we really care about making these algorithms better. So here comes the stakeholder part, right? So we care about the listeners' satisfaction, but we also have multiple other stakeholders, right? So the artist is really important. The creator itself is really important because they also have an audience they want to basically obtain from Spotify, right? So they actually want audiences that come back to them instead of just one-time listen. Okay, we're not a fan. Goodbye. So artists, we also want to basically drive earnings for artists that are not as popular. So we want to boost the amount of artists that can make a living out of our streaming platform, right? So that's the company objective, right? Then we also care about a bunch of other objectives, such as the amount of discovery a custom gets and all that, right? So this makes up like a huge set of meta parameters that we can tune, refine in combination to the ML model's hyperparameter, right? So basically we want to drive this like combination of this, like we want to make sure this recommender system performs as good as possible on different user segments, right? Spotify is obviously available worldwide, and obviously listeners in India or in Indonesia or Brazil is quite different from the ones in the United States. And also new users behave differently than premium users, right? And finally, we have a large set of features from the playlist side, from the artist side, and from also the user side. So we have all these interaction features between the three parts of the model, right? And basically, all these is great, but in the end, that means all these mechanisms causes a huge correlation problem in our algorithm, our evaluation, basically, right? So typical traditional ranking algorithm metrics, evaluation metrics like NDCG doesn't really correlate to the actual online business metric we want to drive, right? So basically the amount, the consumption rate of the user on this playlist and etc. Right. Another problem we run into trying to iterate on these models and sequencers is that the A/B test capacity is always packed because many different teams actually want to iterate on different parts of the whole sequencer. So if the A/B test capacity is almost always at like at least 80%. So at least 80% of the users is in some kind of A/B test. And finally, we have a huge amount of hypotheses stemming from all these stuff we can test, basically, right? So we want to make the evaluation as fast as possible, and this is just not possible with just the amount of A/B tests we can create at the same time, right? So we basically want to simulate these online metrics offline, and this is where our evaluation system comes into play, right?
Would you mind for just a second, for people who don't understand this online offline difference? I think it's pretty fundamental. Would you mind just taking a moment explaining, like, what do you mean by online experiment versus offline experiment?
Offline experiment is when you are not taking the whole system online, right? You are not measuring any change in metrics on actual users. You have some kind of, in offline experiments, you are actually just evaluating on a data set that's not actual users. In online experiment that normally takes weeks, you are actually making the users use this algorithm, sequencing algorithm, or some kind of change that you are trying to make and roll out, right? So the difference is when if live, the users are actually interacting with it, and the offline experiment, it's only some kind of evaluation. You're only performing some kind of, you're only calculating some kind of evaluation on some data set.
So is it like, a long time ago, I was an intern at the Nuclear Regulatory Commission, and one thing that they did was they would have these power plants in, well, anyway, these like simulated scaled down things, and they would run like actual, like, kind of, they would pretend to break a pipe, and it's a 1/16th size of a nuclear power plant, and they would do it whatever, but they would use that to calibrate models, and then most of their testing was on these models. Is it like kind of that same idea of you get some real data, and then and then that allows you to sort of make your simulations?
Yeah, definitely. Yeah. So we're using we're basically, in our evaluation platform, we're performing simulation of the whole online system.
Yeah, that's great. Thank you. That's great.
Yeah. So on a bird eye view, this is how the evaluation system works, right? So we have interaction logs, the impression logs of the user playlist interaction data from the production policy, which is basically what if in production, what if the users actually interacting with, right? So we have the history from the production policy. Then we want to test out if the treatment policies, the top left, are better than the production policy, right? So basically, we're making some kind of change within the sequencer that we want to test if it's better, right? So ML models, different algorithms, heuristics, autotuners. So we have this simulation engine, which is based on causal inference and counterfactuals, basically. So basically a simulation algorithm that tries to generate an offline version of the online metric, right? So basically, if like a video game kind of, right? You're trying to maximize the amount of consumption your user is getting in an offline setting, right? So we're basically from this evaluation system, we're generating this offline online metrics like the amount of consumption, the stream share of less popular artists because we want to make sure they get seen by the public, the proportion of long listening, which is like a metric that we really care about because we don't want the user to just listen to two or three tracks in a session. We want them to listen to at least some percentage of the entire playlist, right? Right. So the workflow consists of basically defining the treatment. We want to re-rank the treatment, basically resequence the treatment, the user data on the treatment policy, right? Then we estimate the online metrics using counterfactual algorithms. Then we finally perform the analysis. What is interesting from like the Modin point of view is that we make sure our data frames here are all independent row-wise, right? So every row actually consists of one user listening session, basically. So you basically have a row of list of tracks, which is kind of weird, but is pretty good for our use case at least. Yeah, so here we have some code that basically, this is basically what our API looks like, right? So we're doing a re-rank, then we have all these parameters that's basically from the treatment policy. And finally, we're trying to perform these metric estimation on these treatment policies. And this exists as a Jupyter notebook and as a COI. So basically any team can basically pull it and run their own treatment policy.
So, okay, so I'm asking a lot of questions, but so are you saying that this is a tool that enables others within the org to do offline evaluation of their experiments? So it's not like you are necessarily, you're not building this just for you to use. Yeah. Internally, there are a number of users.
Yeah, there's a number of users. Our team primarily uses this, but there's other teams that do A/B tests. They want to like simulate A/B test on this platform.
Yeah, cool. Okay, great. Thank you.
Yeah, and also, so this is literally the first row of this slide, right? So basically, there are also data scientists and business analytics team that are actually trying to use this, right? So we want to make sure. So okay, so first, why are we migrating to Modin? I don't think I put it on this slide. It's because native pandas is really slow on these algorithms, as you can imagine, right? So we have like set of 5-6 different estimators, right? Then we also have all these treatment, all those evaluation metrics we want to calculate using these estimators, right? So this is really slow, and this is primarily the reason why we want to use to Modin. We want to move to Modin or some other parallelizable packages, right? So why Modin instead of any other alternative, right? So basically, we want something that's not just pipeline specific, right? So PySpark and PyVim are very pipeline-y, right? They're basically pipeline packages that you can run on the cloud or somewhere in a cluster, right? And this is not really easily modifiable in our term because a lot of the data scientists and even including us were constantly making changes we realize we're constantly making changes within the notebook itself. right? So we want to make sure this is easily modifiable. We also want to make sure this runs on the cloud easily, just as easily as you can run on your local cluster of CPUs, right? So I think I already talked about PySpark and PyVim, and I think they're a bit too basically not mailable for our use case. Then Dask, we're actually was using Dask at some point, but we're only using Dask to run our CPUs, and we don't really have any official support from any platform team to use Dask, basically. And we can also use barebone Ray, but that's a lot more complicated for no reason, since all our estimation is done on Pandas, right? So we decided to basically use Modin plus Ray, because first, Ray is becoming officially the supported, right? So they've a huge blog post by the ML platform team about this, which is basically they decided to adapt Ray because it's the most extendable cluster platform out there. If easily you can easily deploy a cluster on our the Google Cloud Kubernetes engine, right? And as you can see on the right, you can just basically kind of deploy many different things on Ray, and it basically acts as a fundamental base. Prior to this, we were using only TensorFlow extended, which causes a lot of trouble for everyone. And finally, Modin, if basically an abstraction layer on top of our existing code, right? So you can basically change one line in some cases. So basically, instead of calling Pandas, you're calling Modin. Right. So this is basically our cloud configuration, right? We have this notebook we're trying to run on a local machine or on a remote dev machine, and where we have all these data set we want to join on Google Cloud Storage and on BigQuery. So basically, we ask from the notebook this data set to transfer onto the Ray cluster. And then the Ray cluster distributes this data frame into different worker nodes. And you can basically control this worker's node by calling Modin, right? So basically Modin on Ray runner basically manipulates the amount of, they basically manipulates the nodes such that you're constantly getting the same operation on the nodes with different rows, right? And we basically have this setup where everything is mostly run on the Ray cluster using a Modin abstraction. And I believe Ponder is working on something which is interesting, which is they're basically compiling Modin / Pandas directly into BigQuery. So maybe in a future timeline, we will use that sort of system just to abstract away from the whole Ray cluster portion of the chart here. Yeah, so this is our like basic setting. I just want to show this all for a second, which is like, okay, we have this Ray cluster with this amount of CPUs, right? And we can actually run the Ray cluster locally, right? For example, I sometimes run the Ray cluster on the M1 MacBook because that thing has 10 CPUs for some reason, and it's actually pretty fast in some cases. You can, basically you can run this Ray execution on the local machine or on a cloud cluster. Right. So about the actual migration itself, as I said before, sometimes it's just a simple change of changing the pandas into a Modin.pandas subpackage. And frankly, this actually abstracts away a lot of things, right? So again, I'm sure everyone here might probably know how Modin works. If like a parallel, if basically running, if you're basically chopping out data frame into different part of different CPUs, basically, right? And yeah, sometimes the version just works. But we also have to make sure a lot of things fits in this paradigm, basically, right? So some of our code base are pretty outdated and pretty of low quality, including my own code. So we have to spend a lot of time getting rid of Pandas anti-patterns, right? So a lot of our code is actually iterating on rows, which is pretty bad. Actually, frankly, it's probably the worst thing you can be doing on Pandas. So we have to spend time to get rid of this. And we have to make sure we're using API compatible to Modin. And specifically, this caused an issue where we were using inner join on one of the estimator APIs, and we weren't really sure where the problem is until we realized that the inner join is not supported. Right. We also have to make sure that we know that most of our data set is row-wise independent, and we have to make sure this is the case for everything, or column-wise dependent, right? So because you want to do this in order to basically apply the map reduce paradigm, right? So that's basically the apply function in Pandas and Modin. And this way you can easily split up rows into different CPUs. Yeah, and you've actually a non-trivial amount of work to get things done on Ray, because first, Ray if you output, if the system outputs an error in Ray, is normally something really strange, because Ray doesn't output good error messages. So there was a lot of work getting stuff working on Ray, even getting Modin on Ray. And finally, we realized there's a lot of speed slowdown because there's data transfer within the CPUs from to and to our local environment, and because these data sets are like gigabyte size, this will cause an issue if you have bad internet, or if just the data set is just huge, right? So this actually makes up a non-trivial amount of the runtime. So did someone talk?
I was about to say the probably one of the most common questions I get is, why isn't Modin speeding this workflow up? What's going on? And I look at the workflow and there's for loops all over the place. Right. So that initial point you made, I think, is a great one. Definitely a good anti-pattern to keep an eye on.
Yeah, definitely.
And I'll say too that this is super interesting to me and helpful. We recently, the Modin team improved sort considerably, and I'm excited to see those sort improvements propagate to merge and to group by. Yeah. I'm also really interested, I guess we could talk more about this later, but really interested to see how things change when Modin under the hood is using Pandas 2.0. That will, that'll happen, and I think that'll be really interesting. But anyway, you can keep going. Yeah, there's a lot to talk about there.
I'm not sure if we're using Pandas 2.0 anymore. We'll have to check. But yeah. Yeah, so here's the speed up result, right? So basically each row here is a magnitude larger than the other. Okay, so I think this first row is missing 1 0 here, but basically this may not seem large, but we're actually testing these on 3 different treatments, and we're also using 4 different estimators plus we're using 4 estimators on 10 different metrics, right? So this, even if it's 1 million combinations, that's still a lot of calculations, basically. But basically you can basically see Modin's plus Ray speeding up our our calculation here by a lot, and this also depends on the core, right? So here I tested this configuration in native pandas, which is just using one core, right? And secondly, I'm testing this on the MacBook Pro, but I'm using Modin Ray on all 10 cores, right? So this doesn't really scale linearly because there's a lot of overhead, and especially considering some of the poor optimized part of our code, right? So you can see somehow metric estimator is actually takes longer time to calculate than native pandas, right? So that's something that we can improve on, right? But basically, even with this slowdown, we can basically see as we increase the size of our data set, the ray cluster running on the cloud gets exponentially better, right? Because first you have 45 cores, and the re-ranking portion of our sequencing, our evaluation, is way less than how you would normally be in native pandas, right? So if kind of if this is not even exaggerated, on the bottom row here, right, we have 10 million, we're evaluating 10 million different user try combinations. This will probably take us at least a week to calculate on just the native pandas, but it only takes around 1 hour in total on the ray cluster. Once again, this is using 45 cores and 3 different instances of this in one standard, right, on Google Cloud. Yeah, so yeah, this is a huge boost. This is a huge productivity boost. I'm sure, right? So it turns out, embarrassing parallelization with a super low hanging fruit for us, because our data set was actually almost made for it, right? We had row-wise independent data frames. All we need to do is to split them off into different CPUs. This sounds simple in theory, but it's probably difficult in practice if you're trying to code this in native Ray, right? You have to perform the whole data frame splitting part yourself, right? But Modin is basically the package, the godsend package for us, because it basically does the whole data frame row sending portion for us, right? That's basically what the Modin Ray runner subpackage did. And on the way, we got a lot of help from organizationally, right? So we have the ML platform team who've really interested in supporting our use case on Ray, right? So they really helped along. They really helped along the way. So make sure if anyone here is trying to do this in a company, make sure they have organizational support, I guess. And I don't think I finished this slide here, but yeah, I'll leave the rest to questions.
Ziwei, thank you so much. That was very insightful. On your last point, I actually had a question. I think there's probably people in the audience at a bunch of different types of organizations, maybe some larger ones that can have a dedicated platform team like you guys, and probably other folks on the smaller end that kind of have to do full stack work. If you didn't have the platform team, if you didn't have Keshi and the team giving you this infrastructure, I'm curious, what advice would you give to somebody that was starting from scratch, in terms of kind of starting from zero and thinking about the infrastructure and how to design this themselves?
Right. Yeah. There's like a lot of stuff, going into how to create the optimal cluster, how to lower the cost of these clusters. For this parallelization use case, I will suggest to see if you can just start from one virtual machine, right? One virtual machine with, I don't know, 32 CPUs that these exist on both Amazon Cloud Service and Google Cloud, right? So start with one CPUs to see if just, I mean, one instance, and to see if running Ray plus Modin on that instance will work for your use case, right? Because really, we don't need a cluster for Modin plus Ray, right? We just need a good number of CPUs.
Got it. And then as a follow-up to that, in your architecture diagram, you showed a couple of components. You showed the Ray cluster, but you also showed BigQuery and GCS.
Right.
I'm curious to hear for steps like the pre-processing and the post-processing, how do you think about pushing that work to the Ray cluster versus doing it in BigQuery? How do you think about the trade-offs between using those different compute options?
Currently in our use case, I hate to admit it, but we do have this huge BigQuery, this huge query for BigQuery to do a lot of joins from different data sets, right? That is, and this works because a lot of our data set is just the historical data set, and we just need the metadata. And unfortunately, there's also more complex features that's pretty hard to calculate on the fly on BigQuery, and it's also just unhygienic to calculate them in BigQuery. So we decided to do them in the notebook / on the workers nodes themselves, right? So yeah, this is hard. It's kind of hard to decouple the preprocessor in BigQuery and the preprocessing in the Ray cluster. But
we have a couple of questions. Thank you so much. We have a couple of questions coming in. We have one about which Pandas method. This is from Mahesh. Which Pandas method saw the most speed up on Modin? Which saw the least speed up? And then we have one more question after that.
Right. So I believe so we haven't really concretely estimated this, but it really depends on. So we basically use a lot of apply, and frankly the speed up depends on the interior function of apply. So some functions, like the metric estimation ones here, we still have a lot of for loops in the functions themselves, in the interior functions themselves, right? And these didn't get really much speed up compared to the re-ranking one, where we're actually using applies, then we're using applies again, right? So I'm not sure about different Pandas APIs, like with the speed up between apply and join, but I know for a fact that the apply speed up depends on on the actual lambda function you're using.
Yeah, that's great. I will say there was another question, and I should explicitly say another question about what are the endogenous variables / on what metrics do you evaluate the impact of the treatment? But I actually think from our conversation before this call, that's one of the things you're not supposed to talk about beyond what you've already said about like here some of the outcome.
I mean, they're mostly like metrics from 1 to 0, like, or like the average tracks. So basically, like the actual online business metric we're tracking in A/B test, right? They're not like interesting from like a computer science point of view, right? They're just like we're just trying to simulate user behaviors here.
Yep. We have another question about how much time is needed to this is from Adrian. How much time is needed to rewrite Pandas scripts to Modin if it has no loop or anti-pattern? And then also, did you compare Modin to QDF? Like
I definitely have not heard of QDF. So
oh yeah.
No. But in an ideal scenario, you will be literally changing one line, right? That's the bare minimum you can make to make the whole thing run in Modin. And if your code doesn't have any antivirus patterns, this should work in theory.
Okay, yeah, cool. That's great. Alejandro, I have a ton of questions. Do you have another question? And we're getting close to the end, but I think we have time for a few more questions.
I have one from Igor. Let's see, what are dataset volumes in the speed up result size roughly? I think that refers to your listening session count when you go from 10,000 to 10 million.
Sorry.
Is it like, what are we talking? Megabytes, gigabytes?
They're roughly in the gigabytes, not quite terabytes, but 10 million user combination is in the gigabytes.
Got it. Is that single digit, double digit? Any idea?
Double digits, probably.
Okay, cool. Karthik, how often is the pipeline run? Multiple times a day?
Yes, and can I add on to that? How and is it run batch, or is it just always called, like, and if it's run batch, what's your orchestration tool? Like, that's one thing I've been wondering about.
So this is an actual like evaluation system, right? So once you have the treatment, once you set up the treatment, this is basically run on the fly if you want to evaluate something, right? So where's the slides? Right. So every time you want to evaluate a treatment, you can basically run this notebook/CLI on your changes to see how the treatment will compare to the production policy. So this is not an actual pipeline in which we have a cadence we run, right? It's like an actual evaluation tool.
Yeah, that makes sense. We have just a little time. I want to know, maybe Ali, if Ali's interested in saying anything. And Ali, you can hop on and say that no, you're not interested. But do you have anything that you wanted to add, or yeah?
I don't know if I have anything to add. I work on the exact same project that Z-Way works on, but Z-Way did all of the work to actually transition it over, and I now just I'm building on top. I took over when it was already transitioned over to Ray and Modin, and now just continuing to develop other functionality. Not necessarily related to scalability.
Right.
And as someone who is just involved in that part, I would say it's very, very easy to use.
But you definitely had trouble onboarding the whole racing, right?
Initial setup was hard, not because of Ray or Modin being confusing though. I would honestly say that's probably more of just a Spotify development.
Yeah, that's true.
Onboarding.
Yeah. The Spotify development made the whole racing a bit harder.
Yeah, we're a little bit in flux at Spotify in terms of what our recommended development environment is, which was made a little bit more tricky when you're also trying to work with Ray and Modin. But once I got development environment set up, actual development has been a breeze.
That's great. Well, thank you so much, Ali. It's so fun. Yeah, it's so fun to have you here. Alejandro, do you have any final questions before we close?
Well, one of the themes in a lot of the stuff that we look at is Pandas versus SQL. And I guess going back to a previous comment you made around the things that are unhygienic for you to do in BigQuery, can you give a little bit more color there on the types of feature engineering tasks that you would much rather do with Modin and Ray versus doing it on BigQuery?
Right. So I guess this kind of go back to like defining the treatment, right? So sometimes if we want to like add a new ML model thing, right, then we will basically have to do inference on the whole data set using this ML model to get some scores, right? So technically, this is basically adding a new feature, and and this is really hard to do on BigQuery, obviously, because you're basically calling an ML model somewhere to basically join the data set onto the newly obtained scores, right? So stuff like that are hard to do.
Got it. Thanks.
All right, Ziwei, any last thoughts for a group of people who are excited about trying to get pandas to work at scale?
Yeah, I think this is definitely a more bird eye talk than anything this meetup had before. So I hope y'all enjoyed that. Maybe it's a nice change of pace, but
this is awesome. This has been super great. Thank you so much, everyone, for coming. And because I always appreciate this in webinars, there are 60 people here right now. We've sort of fluctuated in the high teens, but thank you so much, everybody. And thank you so much, Ziwei and to Ali as well. All right. Have a great day.
Thanks.
Yep.